So hi everyone, my name is Bernd Szaratuver. I am from PyData Budapest community, and I'm here to extend a kind and short invitation to this year's Budapest BI conference, because we have a PyData track at Budapest BI going on for years, where we are discussing all things related to PyData, from data engineering to machine learning and data visualization. Our CFP is now open, so we are inviting everybody to submit a talk there. And there's a few things which would be good to know about PyData, about Budapest BI Forum. This is not just PyData, it's a multi-track conference where we are also doing tracks on R and machine learning and data visualization. So it's kind of a good opportunity to have a look into other area of data analytics behind PyData. There is some fun things as well, like we are doing a data viz challenge every year, and the conference you can play and interact with the best submissions. We have things like the GDPR Air Shark, which is a very good thing for people whose work is affected by the GDPR, like mine, for example. And of course, there is social activities where you can try the local foods and meet with other speakers there. We do have a quote for female speakers, and we do many things to try to encourage diversity, by the way, I think it's important. So a final thing, that Budapest is actually a good place, I believe. Who has been there already? Well, did you like? Yes. Oh, thank you. You know, we have classical architecture, we have our famous wellness spas, we have our even most famous ruin pubs, and we even have geeky things like Europe's largest pinball exhibition.
Best thing ever.
Thank you very much. So, if you're interested, check out our PyData page, or consider submitting a talk to the CFP, or just reach out to me if you have any questions. And I hope to see you at Budapest in November. Thank you.
Hello, everyone. I'm Agata Somowska, and I will be talking about radical engineers. So we're at the moment facing rising inequalities, global warming. We are in a threat of mass extinction. So what we need to do, we need to radically rethink our solutions and radically rethink the economic and social system that produces those symptoms. The organization I'm talking about, Radical Engineers, its mission is to connect radical organizations working on those issues, working on bringing post-capitalist, important distinction, post-capitalist economies, and bringing them together with community of software developers, data scientists, and designers. We have organizations that know the solutions to these problems, but often they lack the expertise and technological knowledge to bring them about. So one of the organizations that we are working with is called ethical.net. It's an organization that provides ethical alternatives to many services that we use daily, such as messaging, email, web hosting, analytical tools. And they need data scientists to help them with optimization of their content through A/B testing. What can radical engineers do for you? Well, it's a great community full of interesting people, thinkers out of the box. So it's a very welcoming community where you can find people like yourselves. And you can find great, meaningful projects that you can contribute to and build your portfolio. We have a meeting that happens on first and third Tuesday of the week in Shoreditch. Want to learn more? Interested? Please do get in touch. We have a website, Twitter, Facebook, email. There's really no excuse not to get in touch. As I was saying, we have Radical Tuesdays twice a month. The next one is this Tuesday. Please do come along. It will be happening in Shoreditch, in Newspeak House, that you can find as well using this Twitter account. Thank you very much.
I'm going to talk about a tool for time series forecasting, which we have been developing. Brief introduction, my name is Pedro, I work at Sky, I deal with network planning, I work with a lot of network traffic data, and every now and then have to forecast it. So, this is a library which we have implemented in Python for dealing with time series forecasting. Focus has been on being easy to use. It has straightforward API. It's very tolerant in the kind of data it can take, and it just works on the default settings. So there is that. There's also a good deal of flexibility in how you can configure your models and how you can configure the things you can do. So using it is a one-liner. You pass it a data frame with your data and get back a data frame with the forecast as well as some additional parameters. If you choose to have multiple time series in the same data frame, it handles it just fine. There is also some built-in plotting using Plotly, so you can have interactive visualizations. As for the inner workings of this, it's based on regression. We have a system for composing model functions from basic functions, which we can use to pass a series of candidate trends and a series of candidate models, and have the system select the best fit based on a metric which penalizes model complexity. This is the set of basic models which we usually use. For the most part, it's linear trends, which may be adjusted for having piecewise linearity. There's also support for exponential decay models. And we support dummy variables, which can be used, for example, for applying events on specific dates. And well, there are several types of seasonality, including weekly and monthly, which work rather well. There is a possibility for users to define and provide their own models, which can be added to the basic set. And it's pretty straightforward. Just lambda functions will work. And yeah, this is what a forecast with various types of seasonality looks like. And that's it. We're on GitHub. Feel free to check out. And any kind of feedback or help would be appreciated. Thank you very much.
Actually, that's my first presentation outside company, so. So I'm Saurabh. I work in Tokyo for a Japanese company. And I'm 24 years old, and I have a master's in mathematics. My friends, they love for pictures. So step first is like study Japanese, learn Japanese if you want to work on Japanese text, because it's a very beautiful language, very concise. Don't need compression because so much information can be contained in like so few words. Or you can just use a dictionary. I mean, but don't trust Google Translate. I mean, it really causes confusion sometimes if you do translate for Japanese language. Don't ever write business email using Google Translate. Yeah, it's, I will like tell you the stories, I mean, afterwards. So like, more like better ways to like learn Japanese grammar, which is relatively easy as compared to other grammars. But the thing about Japanese is like it has like the vocabulary, it's pretty like big. So you need to like remember a lot, memorize a lot. So for that purpose, we're gonna just use the dictionary. So there is a very good dictionary extension for Chrome. So you can like just hover over the text and if you have like some idea of grammar, you can like just read the sentences. And for offline things, just pretend that you can speak Japanese. There are some like YouTube videos like which gives you like some phrases, so you can like and use those phrases to like pretend that you can speak Japanese. Well, my coworker is here. She is. Okay. So I mean, to read it pretty easily. 僕は日本語が大好きです. It means like I love Japanese language. So and like you can read it pretty easily if you just know the grammar and just use this dictionary tool. Just hover over and you can easily understand Japanese. Step 2 tools for language processing in Japanese. So Japanese language don't have any spaces. Like as compared to like most European languages, they are like separated by spaces, so you can easily tokenize them. You like just split at the word endings. So, but like for Japanese, you need a tool to tokenize them first. They have this tool for Japanese called Mikab. It's pretty easy to use. You can just it's developed by Nara Institute, and it's pretty easy. It does a pretty good job tokenizing. So for example, like here there's a string. It means I love Python, and then it can like tokenize it pretty. And then there's like a POS tagging as well. So you're gonna like so you can like tokenize and like give you the like information like what is it? Is it like a noun or like a particle or adjective or something? Or you can just use sentence piece. Sentence piece like is language independent, and it can like work for mostly all languages. Especially, it's pretty handy for Chinese as well. Next up is canonicalization. I mean, in Japanese, you can like write the same thing using in different ways. So like Japanese. They have like 3 main scripts: kanjis, which are Chinese characters, and then hiragana with like 46 characters, and then katakana, which is used to like write foreign words in Japanese. So for example, like for a soy sauce, there are like in different ways you can write soy sauce. Fun fact is like on our database in Cookpad, it's like there are like more than 100 variants of soy sauce. So like, I mean, people love like, writing it in different ways, which like makes our job difficult, to standardize things. And if you have a generator, like text generation model, then yeah, you don't want him to like, pull from 1,000 words meaning the same. Also, they have like half word, then full word variants as well. So these characters, they are like also characters that like can be like half word, so which have like a different UTF code. So it's a bit of a problem. You can like solve the canonicalization problem. Oh shit. Using an encoder-decoder model. I mean like character-based encoder-decoder model. So you just just choose a text and encode it and then decode it accordingly, and then use fast text for representation learning because it enriches. 2 more minutes.
My first time speaking at PyData as well. I've just come back from 2 years in America on a Fulbright scholarship, learning the tools of technology to study technology and how it is impacting our society. Along the way, I've met a number of wonderful people, but probably top of the list is someone who's very familiar at PyData, and that's Bhargav Veda, who I've been working with. I'm firstly going to present the headlines of my research under the advice of Professor Ben Soltoff, and then we're going to talk about a project which spun off from my master's thesis. Smartphone dependence. This word can be used to describe a situation where the smartphone device is the primary device that an individual has to access the internet. In the US now, this is 15% of the population. And I was interested in researching, who is this segment of society? Is this a new vanguard of entrepreneurial people, or is this just a new way that, a new digital divide, so to speak? So it was Python time, ran the machine learning models. Funnily enough, you might have noticed, given that there are 14% of the population smartphone dependent, logistic regression is actually the only model that actually has higher accuracy than just predicting that nobody is. So if you wanted to try and improve on some of these models, please do feel free to jump into the code on GitHub. But running the logistic regression, what's really interesting is that, with smartphone ownership, it's not that surprising to see that education and income are positively related. But when we look at the smartphone dependence variable, the direction on those variables switches, which means that lower socioeconomic status individuals are more likely to be in this, have this state of their technology. Now, you might be wondering, like, why on earth does this matter? Does this have any implications for the future of these groups and for inequality? Proud to introduce Bhargav to say a minute.
Hey, so I think one of the things which first kind of shocked me was learning about attention engineers, which are just a bunch of people in Silicon Valley who are literally figuring out how gambling machines and things like that work so they can engineer our smartphones to get our attention better. There's things like batching Instagram likes so that you check it in certain times, and it just blew my mind. There are people like actively working on hacking our brains. And like Lawrence was talking about earlier, how most of the people who are using smartphones are like entirely dependent on only their smartphone as their primary internet source, happen to be from poor socioeconomic backgrounds, which means that they're more likely to get screwed over by this kind of technology. So I think some of the cool work which Lawrence is doing is trying to show people that, and also, of course, the extension that there's a whole bunch of research which suggests that extensive smartphone use and living on your smartphone leads to increased anxiety, depression, loneliness, FOMO, and a whole bunch of generally horrible things, there's a whole bunch of research which suggests that, but people aren't really taken serious into account how bad smartphone addiction is. And yeah, so it's just something to think about. And I think I'd like Lawrence to share one last interesting tidbit.
Thank you, Bhargav. It's been an absolute pleasure bringing Bhargav into my spin-off project, First Week Flip Phone. This is a really practical way of challenging people to rethink how they are using technology. And it is a challenge to, for 7 days, give up this device to a friend to look after and challenge yourself to instead use a device that looks a little bit like this. The challenge is extended to everyone in this room, of course. I wish you all the best of luck with your technology in the future. Thank you.
Okay, so yeah, my lightning talk will be something about pandas, which is a lie because I think somebody filled it in for me, and I think that person is Mark. Actually, I'm talking about something about Pip. So yeah, this lightning talk is I need to thank Alex for that. I do believe maybe he already catch the flight back to Germany, but anyway. Yeah, I hope it's recorded so he can see it later. Because like a couple of days ago, we met at EuroPython, and then like he kind of have this idea of like, oh, how do we know that which, like when you do a pip install, like which, because like you have pip install something so you can use, and then like after a while, you'll be like, oh, what have I installed in my environment so I can reproduce it on Binder or something, and then you look at, like, you can look at it by pip freeze, right? But or pip list. So what happened is like it will give you all these dependencies, which is like, oh my god, some of them is like I don't know what they are, but I just have it because I installed something else. So I tried. So he got this idea of like, can we find out which one are the one that I installed actively? So unfortunately, we can't like have a simple solution. So I tried to write some code so I can figure it out. First of all, because remember this like pip list, I can have everything, right? So basically, I'm extracting this. So I put it like into your sub-processing, and then put it in basically this all packages will show you all the list of packages that I have. So so for actually like I didn't know that before. In pip, you can kind of pick a packages and say pip show. I will show you the packages of like all this information about it. Actually, the author of this package will write on the setup tool. So if you have been to the setup, the packaging and conference, then you would know more about this one. So yeah, so this 6 is actually required by the other packages that is on your environment. So you know that this 6 packages, I didn't install it actively because maybe I installed some of those, then it installed it for me. So what I can do is like I can cache all this information. It may take a while, but yeah. So basically, if you look at this thing, right, this required by is what this packages is required by the other packages, and requires, that means that if this one is requires other dependency, that it will show here. So yeah, this take a while. That's why I do a cache, because I gotta capture that like more later. So what I can do is I just like put all the packages and do like a pip show with all of them. So now like what I do here is like I take all of these, and then basically I'm checking these ones. If I split it, do I have like just required by with nothing, or like or I have more? So I pick out there's like 4 packages left that is like only It's only required by, so it's like required by nothing, right? For example, this Ginger is like showing me that it's required by nothing. But wait a second, I never installed Ginger 2. Actually, in this, I create a new environment for it. So basically, in this environment, I only have Jupyter Notebook that I was installed, and of course pip. But yeah, why there's like 4? I never installed Ginger 2. I never installed what does it call, like Pygment? I don't know how. Pigment. So I don't have it. So why? And then so I think. Maybe because the capital of Jin that like kind of mess it up, because if I show notebook, for example, then actually it requires Ginger 2, right? But it doesn't. But when I check it, it doesn't show here. So I think there's something wrong maybe with pip. But before I can send a PR to pip, which I have to understand how it works, I could do something like a workaround, which I check, the other way, right? I check if any requires that is like have Ginger in it. So at the end, I did something wrong. Oh, okay. It wasn't showing this before. Oh, I think I do this. Okay, I don't know why, but yeah, it's supposed to be just showing 2, so I have to fix it. Sorry, I don't know why it doesn't work. Yeah, dangers of live coding, so that's it. So that's piptree, and the message I want to show here is like, please use environment control. Don't rely on pip, and then you will make some like really crazy things like this, which you don't know what you have installed. So yeah, you can use. If you have been to the packaging conference, then you will know that like we can create different virtual environment for different projects. So yeah, thank you.
Well, this is PowerPoint. Clearly, I'm not real. Many of you know me. If I've done lightning talks, I've done other talks before. On this occasion, I'm following the evangelist corner, because the too long don't want to pay attention. A new report came out from the Royal Society recently, which I had a minor hand in, called The Dynamics of Data Science Skills. We're all very lucky, generally, in this room. We are highly in demand across many, if not all, sectors. And what the Royal Society, who I think I'm right in saying date back to 1660. So we may be a modern thing. They definitely aren't, but they have latched on to the fact that we have a skills problem. There are lots of tables, there's loads of data. This was meant to be a 20-page report. It turned into 103 pages with 2 appendices. So it's not a light read, but I would encourage everybody to go. There's a link there, or you can just Google for it. Download it, have a look. It's about what we as society and as a community need to do to tackle many different things if we want to have these skills and use these skills and engage with the future of society and how it interacts with AI and how we can have a data literate populace. Everybody loves a map. I was surprised at the growth in data science related jobs in Northern Ireland. You would have thought it would all be London-centric. It actually isn't. I mean, these are proportional growths. Part of the key point in the report is about the fact that you have an interface between academia, industry, and the public sector. I'd also throw in charity, third sector in there as well, but then I'm a data kind volunteer. And there are a lot of recommendations. And the way they kind of framed it is they looked for good practical case studies in how people are already trying to do this within different communities. And they're there to inspire people to engage with. So things like developing skills in the workforce. There's how do you partner between universities and employers? How do you develop data science into a profession in a coherent setting? How do you enable what they call braided careers, where you can easily move between different sectors? What else do we have? We have enabling movement. So there's the braiding. There's recognizing diverse research outputs, trying to get academics to potentially engage more on commercialization. There's also widening access. So this includes things like DataKind, of doing pro bono work, of actually donating those skills talents back out. Providing access to computing power. If universities have got HPCs which are sat there not doing anything, maybe you can engage and actually share that, so we're not just burning power for no good reason. Also encouraging good data practices. And beautifully, there's, dovetailing onto the final keynote, there is definitely a shout out to the problem we have in a leaky pipeline, and that diversity is everybody's problem, not just the people who are underrepresented. So I highly recommend you get in, have a look for places you can engage. Part of my involvement is because I'm currently an entrepreneur in residence. And I'm advertising this out there because the round is currently open for applying for this. It will end in September. If your employer will allow you to have 20% off to go and engage with a local university for an entrepreneurial innovation style project, they can get up to 20% of your salary paid to them directly by the Royal Society, along with a travel budget and everything else, up to a max of 20K a year for 2 years. It's an experimental program. This is the last of the initial 3-year run, so there's no guarantee there will be any more of these after September. It's been a huge success. I've loved it. I've engaged with other people in other sectors. It has me having all sorts of conversations about interesting things. So if you want to know more, find me. Some of my contact details are on there. Thank you very much.
Okay, so this is a talk called pandas.read.fwf. It's based off of some independent work that I've been doing relating to financial data sets. We're at PyData London. It's Sunday, July 14th, 2019. I'm James Powell. If you're interested in this, please follow me on Twitter. There's actually a call to action at the very end. So you're using pandas, and you might use read.fwf to read a fixed width file, and you pass it some data file. And if you look at the help of read.fwf, you can see there's a couple of arguments with the ** keywords. And if you wonder what those ** keywords are, they're more or less the options to read CSV. And so when you run into trouble with read.fwf, you probably will just look at some of these options, randomly pick one of them, and see if that fixes your problem. Because that's mostly what people do with read CSV. Oh, I need a header. Let's see if there's in there. Oh, I need to parse the dates correctly. Well, unfortunately, for the particular file that I was dealing with, it was about 1 gigabyte in size, and it ended up taking me 60 seconds to process that entire file and 10 gigabytes of memory to process a 1 gigabyte file. So behind the scenes, Pandas was doing a lot of stuff that I didn't want it to do, and I was wasting an enormous amount of time. In fact, if you really sit down and wonder why is this so slow on Pandas, it's pretty obvious. One, the Pandas operations are very safe, and they're very ignorant. I don't have to know anything about the data file. I don't have to know the format of anything there. Pandas will go and try and make a lot of guesses about what the contents of that file are and provide it to me. And if I don't like those guesses, I'll look through that enormously long list of arguments and figure out which of those arguments tweaks Pandas' guessing routines to just work. It turns out that I actually know a lot about this data, because the data I was looking at was institutional data that a client was paying a lot of money to have access to, and it came with a very thick manual explicitly saying, this is what the columns are, this is what's in it, and if that documentation was wrong, that was a contractual problem, and so there was a very good guarantee that if this is a date column, it's always going to be dates, and a lot of this guessing that Pandas was doing was completely unnecessary. And so it turned out that in exploring some of this problem in my own spare time, I found that there were speedups at every step of the way. It's amazing how trivial of a speedup you can find in Pandas data loading functions. For example, this used an enormous amount of memory. And you're all familiar with how certain operations in Pandas will have an in-place keyword argument, and sometimes you can pass in false there to have the, or true there to have the operation performed in place so a copy isn't done. It turns out in practice it's a little bit trickier to actually manage, because sometimes you're not sure if behind the scenes some kind of memory is being copied. And so actually controlling your memory use is very difficult. One of the reasons why controlling memory use in this case is important is this one gigabyte data file was actually one of 3,000 files that we were trying to simultaneously import. And so ideally, the less memory that one reader can use, the more we can parallelize this across all of the files. And so the more that we can have one machine actually process. So a very simple optimization that we can perform is, instead of reading this into Pandas, what we'll do is we'll read it into a NumPy ND array without making a copy. So we'll take the raw byte buffer, tell NumPy this is a NumPy ND array, and then we'll use NumPy rec arrays in order to split up the individual columns. Because it's a fixed width file, we can do that because we know exactly where a column begins and ends. And then we can perform the column transformations ourselves directly. Now, it turns out when we're performing the column transformations for a financial data set, it's not uncommon for that financial data set to have ASCII or ISO 8859-1 encoded data. And I need to turn that into a Python Unicode string, which means I have to do a decode operation, which makes a copy and is incredibly slow because it'll do a linear scan of the entire block of memory. However, it turns out that with a little bit of Python, what you can do is you can grab from inside Python the code that constructs a Python string with a reference to the underlying data set, and you can just say, no, don't decode it, just assume this is a Unicode string, and that works because ISO 8859-1, like ASCII, is actually a strict subset of Unicode. And so this works. You don't even do the decoding, you just say, you know what, this is actually Unicode, don't worry about it. It turns out even for integer and double, in Pandas what would you do? You use a pandas.toNumeric, or you do an ND array as type, And if you dig deep enough, you'll find that this eventually calls within Python PyOS string to double, which is a very safe routine that handles things like exponentiation, that handles negative signs, that handles extra padding. But you can write your own trivial unsafe version. I found that in about an afternoon, if I wrote a very trivial, like a CompSci 101 unsafe version of A2L or an equivalent for turning a string into a floating point number, and I didn't handle spaces because I know it's fixed width. I didn't handle exponentiation. I didn't handle negative values, and I handled fixed point values. I get a 20 to 30% speed up on just converting a string to an integer or converting a string to a double. Now, for date fields, you might use pandas.datetime, which does an enormous amount of guessing, because sometimes it'll use dateutil.parser.parse, which is very slow because it guesses. It uses something akin to a regex to guess what the format is. Now, there are some fast paths within pandas for ISO date times. But for this particular case, it wasn't an ISO datetime. It was a datetime in this particular format. And it's not uncommon for me to see things like this, which maybe represents monthly data or quarterly data. So it's not really a datetime. It's some kind of interval. Or for me to see some weird datetime format like this, like day, month, year, or something even more atrocious like this. Some Thomson Reuters tick history data is actually in this format, where it's like July written out, dash, the date, and then the year. And then you have to do some mechanics and some copies to actually parse it. Well, you can pass in a format argument to pandas.toDatetime, and that works. But a better thing that you could actually do is, it turns out that for a datetime or a time, there's only a set number of finite values, so it's much faster, significantly faster, like 30% faster, to find all the unique values, parse the unique values first, and then map them back. In fact, it turns out that what you want is a datetime 64 object. And so you need to do some kind of object construction to fit the data into the format that you want. And so if you have a YYMMDD, which is a byte string, this is 8 bytes, which means it fits into one 64-bit register. You can play some tricks, so you can fit that into a 164-bit register, use the first 2 values to do 2 levels of lookup, use the last value by addressing that register differently, so you can get exactly a 16-byte or an 8-byte integer, use that as an offset into a strict array that has pre-cached all of these values, and you get some significant speedups. Now, I didn't go that far with this particular example, but it's actually surprisingly possible to do. Now, with just a couple of these very simplistic approaches, maybe an afternoon or 2 of work, I was able to take this down to 10 seconds and 1 gigabyte of memory, a 10 times memory improvement, and a 600% speed up, with very trivial approaches. And so I started to speak to a couple people about this problem, and I think that there's a need, at least within the financial sphere, for an open source unsafe readers package, reading fixed width files and CSV files. I've spoken to Travis Oliphant at QuantSight and Wes McKinney at Ursa Labs. I think you could start a project like this, specialized to financial data sets, and in fact, there's a thought as to whether you can actually look for institutional funding, because this is something that could very much improve any particular organization's ability to process data. There's a lot of assumptions you can make for financial data because, for example, the dates are usually only from 1970 to today, so there's a lot of these little chip away, unsafe optimizations you can perform. And so if this is something you're interested in, please follow me on Twitter or come and speak to me. It's a project that I think would be very valuable for at least one niche, maybe valuable for other niches, and I'd like to see if we could try to maybe build an open source project directly with institutional funding from people who would benefit from it. Thank you so much.
So, I'm a data scientist, and I'm also a brewer. Later you can tell me which one should be my actual job. And I'm also the last person between some of you and the pub, so I thought, we should as well stay on topic. Anyway, if you don't like beer, you can still enjoy this talk, because this is going to be about over-engineering. On the other side, if you do like beer, my suggestion is that instead of chugging one pint after the other, you kind of learn about beer, learn about styles, beer culture, how it's made, where it's coming from, and so on. So let me walk you through brewing. First of all, ingredients. You have 4 core ingredients: water, malt, hops, and yeast. If you're German, you're going to be strict about this. They have a purity law and so on. If you're Belgian, there is some creativity, and then all different beer cultures are equally interesting. That's ingredients. About the process, this is something you could do in your kitchen. Okay, so mashing means putting the malt together with warm water, kind of a porridge. You let them be in a controlled environment for some time. Then you take the grains off, bring everything to boil, add the hops, cool it down to room temperature, and that's done in a few hours. Then fermentation will happen in a couple of weeks, and you're ready to go. So that was ingredients. You have the process. Now we need a recipe. That's an example of a recipe. That's a complex one. You have a lot of things going on. You have a lot of different types of molds, a lot of different hops and different temperatures, different steps. So it looks complex, but essentially if you're a brewer and I give you this, you should be able to replicate the results. And the results turn out to be quite good, as some of you know. This is mine. So I've been doing this for a while, and I feel quite comfortable about coming up with my own recipes, but I still like to go online and see what is going on, what people are working on. There are a lot of online forums where people share recipes, ideas, techniques, and whatnot. So I still look for inspiration these days. And essentially, people in the brewing community are very much open source, if you want, open source oriented. So people who share their ideas online are very nice, and people who share their ideas in a machine-readable format are very, very nice. And now that I know that I have a machine-readable format, I want to automate the process. So I wrote a script to download recipes in the XML format, and then to convert the recipes into a text format readable for me, kind of standardized. So I ran a script, I let it be for a while, then things got out of control, and now I have 80,000 recipes. And I'm not going to read 80,000 recipes because they are 80,000. So how can I automate the process? Well, if you want people to take you seriously nowadays, you have to talk about neural networks. And here we are. According to Vincent, there were not enough talks about deep learning this year, so here you go. So I wrote some neural network application, and then because I do NLP, and when you have a hammer, everything must be a nail, I try to apply my NLP-oriented neural networks to the problem. So I look into recurrent neural networks for sequences. That's, you know everything about recurrent neural networks. And in particular, I decided to dig deeper into long short-term memory, LSTM. So that's the theory. In practice, we want to use Python. And TensorFlow, PyTorch, you have all those tools. I just chose Keras because I don't know any better, so kind of the first one that came up. I write a few lines of Python. Long story short, now I have an AI that can generate beer recipes. Now, sometimes it's good to take a step back. And there are some questions that you may want to ask. So first of all, is the beer any good? Well, not yet. Still working on it. Are we taking the fun out of the process? Yeah, probably. So I guess for the time being, I'm going to stick to manual labor. Now, some of you have seen this talk already. Now, the reason I decided to give it again is that I knew Leah was going to be here, so maybe we can ask NumFOCUS to fund the 2020 PyData branded custom beer. That's the end of the talk. This is also the end of the conference, so apart from the beer, we can also think about, what you would like to see next year. We've been talking about diversity. Maybe we would also like to see more diversity, both at the conference and in the leadership. So maybe we can think about it all together, and in general, you can tell us how you enjoyed the conference, what worked, what didn't, and how we can improve the experience for everybody. We're going to wrap it up shortly, yeah, closing notes. Can I have my co-chairpersons?